Alright, downloaded a new recorder. Let's try this again. Welcome back. This is Scholar Strive doing some math. Doing some algebra 2 today, graphing exponential functions. So, last time we looked at exponential growth and decay, and they look like this. Y equals a 1 plus r for the exponential growth to the t power, and then our decay was 1 minus r to the t power. So our growth factor was 1 plus r, and our decay factor was 1 minus r. So let's look at some functions that would most likely, how to generally look at these graphs. So here we go. Let's start off with a function. So when we're growing, we have a number bigger than 1. So let's just use a basic number, let's say 2 to the x power. Okay? That means we would have like 100% growth rate. So what it would look like, make our XY table. We would use just a standard -2 to +2. And then punch in our values. So 2 to the -2 is actually equal to 1 over 2 squared, which is 1 over 4. This will be 1/2. Anything to the 0th power is 1. 2 to the first is 2, and 2 squared is 4. So when I graph this, so here's 1, here's 2, 3, 4. Here's 1, here's 2. So here's a 4th, here's a 1/2, here's 1, here's 2, here's 4. So we got something that looks like this. So our domain, I can plug in any x value into that equation there, and I'll get something. So all real numbers. Range, notice how it keeps getting closer and closer to 0, but never touches. So y is greater than 0, and our asymptote is the line that it almost touches but never does, is y equals 0. That's the horizontal line. The x-axis is represented by the line y equals 0. So let's look at the decay factor. So this is y equals something less than 1. So we have like some sort of fraction that's less than 1. So let's use 1/2. So this is 1/2 to the x power. Make our table again. Or x, y, -2, -1, 0, 1, 2. So when we plug in -2, remember we're gonna flip the fraction, make the exponent positive. So this is actually going to be 2 squared, which is 4. This will be 2. This will be 1. This will be 1/2 to the first, which is 1/2. And this will be 1/4. So basically it's 1, 2, 1, 2, 1, 2, 3, 4. So 2 at 1/4, then 1/2, then 1, then 2, then 4. So it's basically just a reversed image of the growth. So at the first one, from left to right, we're going up. And then for our decay factor, from left to right, we're going down. But once again, y is greater than 0. It approaches the line y equals 0, and our domain is all real numbers. Okay. Well, let's look at the general form. So the general form for both of these is the same. So once again, both for the growth and decay model, the general form is the same. I'm just going to write it down once. This is y equals a. That's our original amount. And then b, we're going to call that our either growth rate or decay rate. And then that's going to be to the x power minus h plus k. Okay? So where h moves our graph left or right, and k moves it up or down. And a, which was our original amount, just stretches the graph usually. Or flips it, or shrinks it. Okay, so a stretches, h moves it left or right. So we use the opposite, remember, of whatever our h is. Use opposite sign. K moves it up or down. Our domain is going to be all real numbers. Our range is going to be y values greater than k. And then our asymptote will be y equals k. Alright, let's do an example. Or 6 examples. There we go. So y equals 2 to the x. So we just did that. Here we go again. So let's fill them in really quick. So our b value is 2. It's a growth because our b value is bigger than 1. It's a decay. So let's look at the second problem. If it's less than 1, like a fraction. But it, yeah. Okay. So b value is 2. In this one, a value is 1, not 0, even though it's gone, but think of it as something being multiplied. Okay. H is 0, k is 0. So our y-intercept is 0, 1. All you do is plug. You just find out where it crosses the y-axis. Asymptote. This is y equals 0. Domain, all real numbers. Range y greater than 0. So I was just copying from before. Because remember, that's -2, -1, 0, 1, or 1, 2. And let's just put in 3. So -2 was 1/4, 1/2, 1, 2, 4, 8. So if we look at this, this would be -2. There. 1, 2, 2, 4, 3, 8. That's what I look like. And you know what? I'm going to skip number 2 because we did that before. We're right above on the last page. Okay, 3. So B is 4. A is 1/2. H is 0 and K is -2. Okay. So I'm just going to do this again. -2, -1, 0, 1, 2. If I plug in sorry, if I plug in -2 into the equation, I get... Alright, got interrupted again. Here we go. So I plug in -2 into this equation here. So let's back up there. So 4 to the -2 is 1/16. And then we have to times the 1/2, which is equal to 132. And so we have 1 over 32 minus 2. So that's going to be some decimal answer close to -2. So we like -1 and 31 over 32. But go ahead and just put this in your calculator. And then this is going to be 1/8 minus 2. And then the easy number is 0. So 4 to the 0 is 1. 1 times 1/2 is 1/2. 1/2 minus 2 is minus 1.5. And then 1. So 4 to the first power is 4. 1/2 of that is 2. 2 minus 2 is 0. 4 squared is 16. Half of that is 8. Minus 2 is 6. All right, let's graph this. So remember, our y-intercept is always at... or wait. Let's see. What did I write up there? Oh, I didn't write anything. Yeah, it depends on the situation. So let's just graph this out. But our y-intercept where it crosses the axis is 1, 0. Because that's there. Oh, wait. Sorry. Crosses the y-axis, not the x. 0, negative 1.5. Okay. Our asymptote is at y equals -2. Our domain, all real numbers. In our range, everything bigger than -2. So that our range is always y is bigger than k. Unless our a value is negative, which will do something different. But we'll show you. And that's how you do that one. So you just plug your numbers in the calculator and then graph it. So this will look like something like this. So 0, 1.5, 1, 0, and 2, 6. So it looks something like this. Always approaching -2, but never touching. Alright, number 4. -3 times 1/5 dx. So label all your correct things. So this is 1/5. A value is -3. H value is 0. And K value is 0. Okay. So I'm just going to use bigger numbers for x. Or no, I'm going to use negative numbers. So I'm going to do 0, -1, -2, -3. And the reason why I'm using negative numbers is because it's a fraction. And when you use negative exponents for fractions, it becomes an easier number to work with. So for example, well, first off, let's do the first one, 0. 0, 1/5 to the 0th power is 1, times -3 is -3. -1, so if we plug in -1, so let's say 1/5 to the -1, all we do is flip the fraction, make the exponent positive. So it is actually 5 to the first. So this is just 5. And then this would be, well, that would be 5. But it's -3 times 5 which is negative 15. Okay. And then we would use some smaller numbers, I guess. So positive numbers, 1, 2. So if I put it in positive 1, I'll get negative 3/5. If I put in positive 2, I will get negative 3/25. So it keeps getting smaller, as you can see. So let's look at 0, 0, comma, negative 3. There's our y-intercept. And our graph looks something like this. Okay, so it's flipped upside down because the a value is negative. Our y-intercept is 0, comma, negative 3. The asymptote y equals 0, so it's still our k value. All real numbers in our range is y is this time as y is less than 0, because our a value is negative. Alright, 2 more and I'll let you guys go. Okay, b value 2, a value 4, h is 1, so it says minus 1 up there, so we're going to use positive 1. K is negative 3. Okay, so our y-intercept is going to be at, I just realized this, I should have put it back up here. So when you're looking for your y-intercept, it'll be h, comma, h, comma, okay. Okay, so let's go back down there. Oop, oop. Oh yeah, so let's look at these really quick. So it's increasing from left to right, so this is a growth. Second one's a decay, this is a growth. Our b value is, this would be a decay function. Our b value is growth, and then decay. So I'm looking at our b value. If it's a fraction, it's decay. If it's bigger than 1, it's growth. Okay. Alright. So you always want to start off at h, comma, k. So this would be 1, negative 3. It's my y-intercept. Is that true? For the others, no, it's not. It's 1, negative 2, isn't it? Because if I plug in 1, I'll get 2 to the first, or 2 to the 0, which is 1. 1 times 4 is 4. 4 minus 3 is 1. So yeah, let's just forget whatever I said up here about the y-intercepts. I'll just erase it there. It's erased. So what I just said about the y-intercept, there's no easy way. You just plug in. Well, we know that the x value is going to be our h. whatever h is. And then to find the y-intercept, you just plug it in. I'm so stupid. Alright. No, I'm not. I keep confusing myself. Sorry, I'm not going to edit this out. But what happened... Ooh. There we go. Alright, so what happened here, I was trying to figure out a rule for the y-intercept. But the rule is always this. Your x value is 0. It's always 0. Okay? And then, because that's where it crosses the y-axis, is at x equals 0. So if I plug 0 into the equation, I will get 2 to the 0 minus 1, which is 2 to the negative 1/2, or 2 to the negative 1, which is 1/2. 1/2 of 4 is 2. 2 minus 3 is negative 1. Okay? So that is my y-intercept. My asymptote, now that always works. That's y equals negative 3. Our domain is all real numbers. Our range is everything bigger than negative 3. Okay. So I'm going to get something that looks like... So let's do here 0, negative 1, 1, 2 to the 0th is 1, times 4 is 4, minus 3 is 1. If I put 2 in there, I get 2 times 4 is 8, minus 3 is 5. There we go. And then if I put negative 1, I'll get 2 to the negative 2, which is 1/4. 1/4 of 4 is 1. 1 minus 3 is negative 2. Okay. And we'll get something like this. Negative 1, negative 2, 0, negative 1, 1, 1, 2, 5. So we get something that looks like this. So it's always approaching this dashed line, which is y equals negative 3, but it never touches. Alright, number 6. B value, 1/3. A value, 2. H is negative 2, because there's a plus 2 up there. And K is nowhere to be found, so 0. So my y-intercept, if I plug in 0, what do I get? 0, so this would be 1/3 to the second power, which is 1/9. 2 times 1/9 is 1/9. Ugh. So 2/9. So if I plug in 0, I get 2/9. If I plug in... If I plug in negative 1, I'll get 2/3. If I plug in negative 2, I'll get 2. Because if I plug in negative 2, that'll be 1/3 to the 0th power, which is 1. 1 times 2 is 2. And you know what? That's all I'm going to put there. So 0 is 2/9. Whatever that is. Negative 1 is 2/3, which is a little bit higher. Negative 2 is 2. So we got something that looks like this. Asymptote, y equals 0, all real numbers for the domain, y is greater than 0. Alright. Hopefully I didn't confuse you too much. Probably be better in class. Alright. And that's it for this video.